Alrighty, once again, Mr. Maley here. I want to show you how to work a problem like this where we have variables on both sides. See how I have an n on the left and an n on the right, and I have some distribution to do with this -8 in parentheses. Alright, so first things first, we want to simplify both sides as much as possible. Okay, that's our first step, is to simplify. Now on the left-hand side, there's nothing I can do there. 3n minus 5 cannot simplify any further than that. But on the right, I can use distribution to take that -8 and multiply it onto the 6 and to multiply it onto the 5n, and that's exactly what I want to do. Okay, so once again, left side, I can't do anything with that, but I could take that -8 and multiply it onto 6. -8 times 6 is -48. And I could take that -8 and multiply it onto the 5n, right? -8 times 5n is -40n. Okay, so that's our first step in this problem. Distribute the -8. Okay, that was our first step. All right, second step, now that we have a variable on both sides and both sides are simplified as much as possible, right? 3n minus 5, can't simplify that any. -48 minus 40n, can't simplify that any. So now I need to move the variable to one side, and it's pretty flexible here. I can move the 3n by subtracting it from both sides, so now that I have an n on the right, or I can move this minus 40n out from the right side by adding it to both sides, and if I add it to both sides, now I have an n on the left. I'm a pretty positive guy, so I like to add whenever I can instead of subtract, and that's what I'm going to do here. I'm going to add 40n to both sides so that it's gone from the right, and now I'll have just n on the left. Okay, so once again in algebra, what you do to one side, you must do to the other. So if I want to get rid of the -40n on the right side by adding 40n, I better add 40n to the left side as well. Now remember, combining like terms and the like families with Romeo and Juliet, the 3n and the 40n, they're from the same family, they're from the n family. They can combine. 3n plus 40n makes 43n. The minus 5 is from a different family. He doesn't combine with anything over there. And all that's left now on the right-hand side is the -48. All right, so my second step in this problem was to move n to one side. And I did that by adding 40n. Step 3, this is actually turned into a two-step equation now. Oops. Our old familiar friend two-step equation, we need to undo the subtraction first by adding. -5 and the +5 cancel, so that means that 43n is equal to -48 plus 5, which is -43. All right, so my third step here was to undo subtract 5. By add 5. I'm going to scooch this down a smidge. Fourth step. Last but not least, I need to get rid of that 43 to get n by itself. See how there's a 43 multiplied onto the n? I can easily get rid of multiply 43 by dividing 43. Multiply 43, divide 43, now it's just n by itself, and if I take -43 and divide it by 43, I get -1. So my fourth step here, undo multiply 43 by divide 43. Last but not least, once again, it's never a bad idea to check. To make sure that we did it right, check n equals -1. And we check n equals -1 by plugging it into the original problem. The original problem was 3n minus 5 equals -8 times 6 plus 5n. So instead of 3n minus 5, now it's 3 times -1 minus 5. equals -8 distribute onto 6 plus 5n. Oops, not n. 6 plus 5 times -1. Okay, let's clean it up. 3 times -1 is -3, so -3 minus 5 on the left. That's -8 times 6 plus 5 times -1. That's 6 plus -5, or 6 minus 5. -3 minus 5 is -8. 6 minus 5 is 1, so this turns into -8 times 1. And yes, indeed, we're good.